Alright, let's solve this question through code. Given this code fragment, what is the probability that a measurement would result in a state 0? So we have a single qubit here in our quantum circuit, and we're going to rotate it about the y-axis 3π4. Giving it 0 means q0, which is going to be the first qubit. So we're going to rotate the first qubit. Let's build some intuition behind this before we solve it more exactly, before we simulate the results. We can give the state vector of the final quantum circuit result to this object, and it will create the theoretical final quantum result that this quantum circuit will give in state vector form. So it'll give the amplitudes, the alpha and beta for the 0 and 1 state. And then we can plot that on the Bloch sphere to get some estimate on where the final qubit will be before we measure it. So here we can see it's closer to 1 than 0, meaning that we should have less than a 50% chance of measuring it in the 0 state, because if it was 50% chance, then it would be in the x-axis or higher, on the x-axis. And so because it's below the x-axis, closer to 1, then we should expect to see 1 more than 0 in the sampled results. And that already gives away the answer. Since we should see 0 50% or less than 50%, then that eliminates A, B, and D, meaning that C is the right answer. But we can make sure that that's actually what's happening, or what will happen when we simulate it. We can measure it, so that way we can simulate the measurement results, get some actual results from it classically. And we will do it on the CHASM simulator with 1,024 shots. Now that returns a job. If this was a real hardware backend, then this job might take an hour to actually execute. And so then when we called result, it would stop and block there. I might want to go do something else instead of just wait here. But because this is fast, then we'll just call the result function right after, and that will return the result once the job is done. We can get the counts for the specific quantum circuit by name. If this was multiple results, then that would give us the specific result for that quantum circuit. And we see from the results that we measured 0 158 times and 1 866 times. So to see exactly the probability of 0, we divide the sampled result divided by the sample size. And so this bit string is going to relate to the 0 state, and when we divide it by the sample size, we see we get the same value as we see in this histogram, which this is a nice way of comparing all the results that we got. And so we can see that our results of 0.137, or whatever results you may get here, roughly correspond to the actual answer, 0.1464.